today's class we will discuss about what is entropy and then what is the second law of thermodynamics in terms of entropy, and at the end we will see what is the principle of increase of entropy. Okay, we will see one by one. Take first entropy. It is denoted by the symbol capital S. What is entropy? It is a measurement of molecular disorder or molecular randomness. Okay, it will measure the entropy will measure the disorder of the molecules or randomness of the molecules. And another definition is it is unavailable form of heat energy. So first we will discuss about measurement of molecular disorder. If in a given system molecules are not in order, that is it is in disorder, then we can say that system has more entropy. Okay. Take example for explaining the entropy. I am taking here solid, liquid and gas. So as we know, in solid atoms are arranged in a regular manner. In liquid they are getting the shape of the container, and gas the atoms are arranged in a irregular manner. Okay, wherever irregularity is there or disorder is there, in that system we can say entropy is more. Okay, so compared to these three, in gas disorder of the molecules is more. Okay, so for this system entropy is more. I am writing S of gas. S means entropy, it is more compared to the liquid. S of liquid. And then if you are comparing solid and liquid, in it disorder is little more compared to the solid. So wherever disorder is more, we can say entropy of the liquid is more compared to the entropy of solid. So entropy of liquid is more compared to entropy of solid. So here in these three, in gas entropy is more because of disorder. Okay, so here how can we measure disorder of the system? Because entropy means measurement of molecular disorder. So it is difficult to measure disorder of the molecules. That's why we can take this entropy in terms of change in entropy. Okay, so change of entropy we can measure by using delta S. So here I am writing delta S means change of the entropy. That is, we can write ds is equal to delta Q by T. It is the formula for the entropy. So delta Q means change in heat divided by temperature in terms of Kelvin. If you are taking the units for heat transfer, we are taking joules. For temperature we are taking Kelvin. So units are joule per Kelvin. Okay, here I told just now ds or delta S means change in entropy can be measured. So here change in entropy is a point function from one point to another point. The difference S2 minus S1 will give the exact value. That's why we are calling it as a point function. Okay, or we can call it as state function also. And it is extensive property. Why it is extensive property means it is depending on the mass of the given system. Here we did one separate video in it what is extensive property and what is intensive property. I will give the link in description box, please check it. Here in this case change in entropy is extensive property. That is the meaning of it is depending on the mass. If you are taking this delta S per mass, per unit mass, we can call it as specific entropy. Okay, specific entropy. Always remember, if you are taking volume by unit mass, we can call it as specific volume. Whatever value we are taking here per unit mass, we can add specific for that term. Okay, here we are taking entropy, that's why we are calling specific entropy. Okay, and this entropy is at water T is equal to 0 degrees C or absolute temperature, that entropy is also 0. Okay, so this 0 we are taking in the graph as a reference point, because in the graph we are taking like this. This is the 0 is the reference line for measuring the vertical heights. Okay, similarly here 0 entropy means this line we are considering 0 entropy line. Entropy for calculating the absolute values of S1, S2, S3 like that. Okay, so always remember at T is 0 degree C or absolute temperature, the entropy value is 0. This 0 entropy is a reference point or reference line for measurement of values S1, S2, S3 like that. Okay, we are measuring from this height will give the S1 value, this height will give the S2 value like that. Okay, so it is a reference. 0 entropy is a reference line. According to this equation of entropy, if heat exchange is more, the change in entropy is also more. if the supply heat or temperature, source temperature is more, the heat or entropy change is less. It is inversely proportional to the temperature. So we have discussed about the disorder of the molecules right now. And now take the next definition of entropy. It is unavailable form of heat energy. So how can we find this unavailable form of heat energy? By using some equation. Let us take one engine in example. Okay, as we know, heat engine is taking Q1 amount of heat from the source for running this engine, and it is producing some useful work, and then it is rejecting some heat to the sink. So always source temperature is T1 is more than T2. Okay. Always remember here, if this temperature is more, we will get maximum amount of work done. Okay. If this is less, we will get the less amount of work. That's why always source temperature is more. Okay. What is the efficiency of the engine here? So work done, let us take delta W by some heat transfer to the engine. Okay. Delta Q. So efficiency of the engine is work done by heat supply to the engine. Okay, let us take delta W by delta Q. Now here, in terms of temperature, the formula is T1 minus T2 is equal to, divided by, in terms of temperature, the formula is T1 minus T2 by T1. Okay, we have derived in the last class in explaining second law of thermodynamics. I give the link in description box. Please check it how this formula is coming for efficiency. Now if you are considering these two terms, delta W is equal to delta Q into, so I am taking these terms as it is, T2 by T1. Now here delta Q, T1 by T1, 1 minus T2 by T1. Okay. So how this will come? Delta Q minus delta Q into T2 by T1. It is equal to delta W. Here I am writing the same thing here. Delta W is equal to delta Q minus, I am taking this is the unavailable form of energy. Okay, this is the available form of heat energy. This is the unavailable form of heat energy. The difference is using for doing work. Okay, whatever difference is there, it is giving the useful work. So here like Q1 minus Q2. Okay, instead of Q1 minus Q2, what I am taking is here delta Q, that is Q1 here, minus, instead of Q2 I am taking this value. So it is coming from this equation. So here this is a available form of heat energy. So this is the unavailable form of heat energy, UHE I am writing, unavailable heat energy. Okay. Now here we can write, so what is the unavailable heat energy formula? UHE. So it is equal to delta Q into T2 by T1. Okay. So here T2 is the sink temperature and then delta Q by heat supply temperature. Okay, Q1 by T1 like that. So what is this term? According to the entropy equation, delta Q by T, heat supplied to the engine to the temperature of the source. So ds we can take instead of delta Q by T1. So instead of delta Q by T1, I am taking sink temperature into S, or delta ds or delta S also we can take. So here unavailable form of energy, okay, is equal to T2 into ds. This change in entropy will find the unavailable heat energy by using this equation. So here I am keeping in one box. According to definition of entropy, it will measure the unavailable form of heat energy. So this is the heat energy. This entropy is measuring this amount of unavailable heat. So this is another definition of entropy. Whatever exhaust gases are coming from the engines, it is unavailable form of energy. We can't reuse that energy. Take next one, second law of thermodynamics. This law is very important law and a very useful law, but it has a little confusion because it has three statements. Already we did Kelvin Planck statement and Clasius statement in the last classes. I give the link, video link in description box. And one more, today we will discuss Clasius inequality. Here there are three statements, so it is confusion for the students. For avoiding this confusion, we give some examples so that you can understand easily. So first, what is the importance of this second law of thermodynamics? It is very important law of thermodynamics. It is also called fundamental law of nature. It will explain the spontaneous processes in the universe. Okay, in which direction the spontaneous process is taking place on the earth as well as in the space. Some objects are moving in the space from one place to another place. So why those are traveling from from that position to another position, and why some instantaneous processes are taking in particular direction. So it is very interesting law for explaining the irreversible instantaneous processes. Okay, whatever processes are taking place naturally on the earth, it is because of some entropy difference. Okay, so that direction and spontaneous process can explain by using the second law of thermodynamics, by using the Clasius inequality. Let us take the Clasius inequality. This law will explain spontaneous processes. Okay, so what are the spontaneous processes? Without any external force or external aid, the process is taking place quickly. Okay, it is called spontaneous process. I am taking some processes here. Okay, now I am taking A gas, B gas in a container. Okay, these two are separated by one wall. Okay, let us assume like that. In next case, I am removing this wall. The gases will mix with each other like this. Okay, it is getting the shape like this. Okay, it will get this process spontaneously without external force. It is getting quickly. Now in next example, I am taking some tea here. Let us assume it is very hot. Now after some time, without any external force, it is getting cool. Okay, now in next example, I am taking some 5 kgs weight lifting here. Okay, this is the ground level. If it is falling, it is coming to the ground. Okay, so without any time taken, it is falling quickly. Now in next example, I am taking one paper. Okay, we are burning this paper. It is getting ash. It is also spontaneous processes. All these processes are spontaneous processes. Okay, example of spontaneous. So is it process is reversible? Reversible means if spontaneously these are reversible or not. Without any external force, we can't divide this A and B molecules separately like this. Is it possible spontaneously? So this is not possible. Okay, without any external force, the reverse process is not possible. Okay, we can't do like this spontaneously without any external force. Okay, here also without external force, again we can't heat this tea in the reverse order. So here also without any external force, spontaneously we can't fix this weight to the hook. So here by taking ash without external force, spontaneously we can't make into paper. So these are only one side, one direction process. Okay, so in reverse order, we can't be do as in initial shape. Okay, we can call these processes are irreversible process. Okay, so here second law of thermodynamics will explain irreversible processes. Clausius has given this condition in second law of thermodynamics for reversible and irreversible and impossible processes. Okay, this statement is called Clasius inequality. According to this, circular integral of delta Q by T is less than or equal to 0. Okay, so if the process is following this condition, it may be reversible or irreversible process. Let us see. Here there are two conditions. Less than or equal to means if this quantity is equal to 0, it is called reversible process. Okay, actually there are no reversible processes. Okay, these are the ideal processes. Okay, reversibility is not possible in practical form. Okay, in the practical way, only in the theory part we are considering for ideal conditions the given process is reversible process. Okay, so practically these processes are not possible. 99% whatever processes are taking on the earth or in the universe, all processes are irreversible processes. Okay, so here in two conditions, if it is equal to 0, it is reversible process. If it is less than 0, this quantity, it is irreversible process. Okay, this irreversible process is getting because of disorder of the molecules. Similarly here, okay, because of disorder, this process is irreversible process. Okay, and now for removing this, let us assume we are getting this value delta Q by T greater than 0. Okay, that process is impossible. in the competitive exams, sometimes they are asking this value is greater than 0. Is it possible or not? That process is not possible. Here I have written delta q by t greater than 0 is not possible process. Okay. Now here, so for removing this less than or equal to, we are adding one term for this. Okay, circular integral of delta q by t plus some I is equal to 0. Okay, it is okay. So it is circular integral of delta q by t plus I is 0. Okay, for calculating the value disorder, he has given this equation in second law of thermodynamics. According to this, if I is 0, okay, so if disorder is 0 here, okay, there is no disorder means it is a reversible process. So here we have written it is a reversible process. Disorder 0 means all atoms are arranged in a order form. Okay, so it is in case of reversible process. So if this value delta q by t is less than 0 means it is a irreversible process. If this value is greater than 0 means, just now I told, this process is not possible. Okay, so this law is telling whether the process is possible or not. Okay, and also it will give the direction to the process. Okay, it will calculate the disorder, how much disorder, and also if you know this value, it will give the change in heat in cyclic integral. If you are taking like this, after the integral, it is getting delta q by t 1 to 2. Okay, so we will get delta q2 by t minus delta q1 by t. We can calculate the direction of the heat exchange. Okay, so Clasius has given the equation to the second law of thermodynamics for finding the direction and also for finding the disorder. Okay, how much disorder that process is, and also it is a reversible process or irreversible process, or that process is possible or not. These are the main uses of second law of thermodynamics in Clasius inequality. And also he is introducing entropy in this second law of thermodynamics. He has given the entropy term for the disorder of the arrangement of the molecules. Take the next one, principle of increase of entropy. According to this principle, universe entropy is always increasing. Okay, as we know, wherever heat exchange will be there, according to this formula, wherever heat exchange will be there will be change in the entropy. Okay, so according to this principle, the heat exchange is more always, okay, in the universe. Because of this more quantity, entropy is also increasing. Okay, entropy of the universe is increasing every time. It is the principle of increase of entropy. So how can we explain that? By using the Clasius inequality. As we know, Clasius inequality is circular integral of delta q by t is less than or equal to 0. So same thing I am taking here. Here, as we know, this irreversible processes or disorder arrangement of molecules is taking entropy. Okay, as we know, entropy is measurement of molecular disorder. Okay, so in irreversible processes there will be disorder. Okay, so that's why we have to take the entropy term here, ds. Okay, so here why we are taking instead of 0 ds. Here circular integral of thermodynamic property, any property, temperature, pressure, everything, it should be 0. Why means in cyclic process, if you are taking the process like this in the graph, okay, so whatever property change in this direction, the same property change in this direction. Okay, in cyclic process, okay, whatever thermodynamic property is there, the sum, integral means sum of this cyclic process is 0. So this thermodynamic property, here we are taking the entropy. Okay, I am taking this in the form of the sum of all the entropies in this whatever given processes. So I am taking cyclic integral. Okay, so here we can remove this side and this side, cyclic integral. Okay, so here we can write the same equation like this, delta q by t, okay, less than or equal to ds. So here this side I am writing greater than or equal to delta q by t. Same thing I have written here. Now here equation, there are two conditions again, greater than or equal to. If ds is equal to delta q by t, it is a reversible process. If ds is greater than delta q by t, it is a irreversible process. Now if you are taking the universe, okay, according to this principle, universe entropy is increasing always. Okay, if you are taking, so here for universe means this is the system, whatever process is taking place Okay, this small space is we are calling system. Outside the system it is the surrounding. If you are combining system and surroundings, it is called universe. Okay, whatever heat exchange is there between system and surroundings, let us assume some heat has exchanged from system to surrounding, it is q1. Let us take from surrounding to system, let us take q2 amount of heat. Okay, for reversible processes, whatever heat q1 is there, it is same equal to q2 for in case of reversible processes. The meaning of delta q is change in heat q2 minus q1. So for reversible means same amount q1 is equal to q2, it is equal to 0. Okay, what is the change in heat in for universe? It is 0. For universe, delta q is 0. Okay, that is equal to ds is equal to 0 in case of reversible processes. So here we have written ds is equal to 0 in case of reversible processes. So in reversible processes, one more important point is whatever heat exchange is there, q1 or q2, it is the highest heat exchange. Okay, q1 is maximum compared to irreversible processes. Okay, so in reversible processes, whatever heat exchange will be there, it is the maximum. q1 is maximum and q2 is maximum, but change in the heat is 0. Okay, delta q is 0, that's why universe entropy is also 0. And then if according to this principle, universe entropy is increasing. Okay, why universe entropy is increasing means, here so many irreversible processes are taking place in the universe. For example, exhaust gas is coming from so many vehicles. Okay, so coming of exhaust gas, it is also irreversible process. Okay, and from so many industries, okay, some exhaust gases are coming, those are also irreversible processes. So many irreversible processes are taking place in the universe. Okay, that is the meaning is the heat exchange is taking place. Okay, so heat exchange is always high in the universe. That's why if heat exchange is there means the entropy is also increasing every day. So ds is greater than 0 because of irreversible processes throughout the universe. So according to this principle, entropy of universe is goes on increasing. Okay, this is the principle for entropy, increase of entropy by using the Clasius inequality. So here in this class, what we have observed in second law of thermodynamics, Clasius inequality will give the equation for the second law of thermodynamics. It will give the direction as well as how much disorder also we can calculate by using the equation, and how much heat transfer is calculating if you know the I value. So we can calculate the direction of the process, instantaneous irreversible process, by using this inequality. Also we can find which process is reversible, which process is irreversible, which process is not possible. So these are the uses of second law of thermodynamics. And also by using this principle of increase of entropy, the entropy of universe is always increasing because of irreversible processes are taking place continuously in the universe.